All right, for the last couple of days, we've been trying to investigate derivatives, and we've been looking at the graphs of derivatives. And when you did the stuff on Desmos, you found the graph, and then you had to go off and guess the equation for the derivative. And what we're going to do today is try and figure out how to find that equation without actually seeing the graph. So we're going to go back and look at the example from day one. When we had that dragster. So the formula on day one, I think, was d equals 19t squared. But we're going to use y equals 19x squared for this case. And we're going to find the average rate of change and shrink that h interval and see what happens. So this is all what we've done before. So when you had to find the average rate of change, we had a formula that f at a plus h minus f at a all over h. And the h was that small interval, the length of the secant, that we kept getting smaller and smaller and smaller. The a value is where the beginning of the interval starts. So since we're interested in estimating the a rock at 3, the a is 3, and then h is the length of the secant. So in our case, this is f at 3 plus h. Oh, sorry, the h is 0.1. minus f at 3 over 0.1. So the f at 3.1 and the f at 3, you could do off to the side and try and figure out, but we can do it right within the question. So we're interested in what the y value is at each of these intervals. So I'm going to do it right within the formula. So our formula is 19x squared, so in this case we're going to sub in 3.01. So it's 19 times 3.01 squared. And then our f at 3 is 19 times 3 squared, all over 0.1. So if we plug in 3.01 into, oh sorry, not 3.01, 3.1. We plug 3.1 into our equation and figure out the corresponding y value. We square it, then multiply by 19. We're going to get 182.59. And if you plug 3 into the equation, you square it, you'll get 9, multiply it by 19, and you'll get 171, all over 0.1. And this comes up with 115.9 meters per second. So that's an estimate of how fast the dragster is going at 3 seconds. We did a small little secant that represents the steepness of that curve. The length of that secant is only 0.1, and we would estimate 115.9. So this should sound familiar. And what we did when we were practicing this formula is we kept shrinking and shrinking h. So we can keep shrinking and shrinking h, but every time we shrink h, we got to start from the beginning again, right? So if we had this case, we had h was 0.1, so we would plug in that 3.1 and figure out all the math. If I wanted to do it again and shrink it again, maybe go to 0.01, then we would have to start over and plug in 3.01. And if we kept shrinking it, we'd have to start over at 3.001. So it would be great if we could come up with an equation that would allow us to sub in all sorts of h values later on instead of at the beginning. Okay? So what I'm going to do is create a formula and not actually define what h is. Instead of saying it's 0.1 or 0.01 or whatever, I'm just going to let it be h. See what comes out, and then maybe that version of the formula will be easier to use. So here, this is still going to be a. We're still estimating this at h, or at x equals 3. So a is 3. But what we're going to do instead of saying that h is 0.1 or 0.01, we're just going to let it be a variable. So this time, it'll be f at 3 plus h minus f at 3 all over h. So we'll plug in, instead of plugging in 3.1 into the equation, we're going to plug in 3 plus h. So it's still going to be 19, except it's going to be 3 plus h squared. That's what happens when you plug in 3 plus h. This part's going to end up being the same because we're still plugging in 3. All over h. The part of this we have to be careful of is when we square this, 3 plus h. Remember that 3 plus h means, or squared means 3 plus h times 3 plus h. So we don't rainbow just the first one, and then the last one we have to rainbow everything. So it's 3 squared is 9. 3 times h is 3 plus h, or 3h. Then plus 3h plus h squared. 9 plus 6h plus h squared. So when you take the 3 plus h and you square it, I've done that off to the side to make sure I do it right. And I end up with 9 plus 6h plus h squared. Plugging in 3, I already know is 171. I did it in the question before, and I've done it a couple of times. All over h. That trinomial has to be multiplied by 19, so I'm going to rainbow the 19 in. So 19 times 9 is 171, plus 114h, plus 19h squared, minus 171, all over h. So at first glance, I said I wanted to do this to make my life easier, but it looks like things are getting harder because you have to rainbow a 3 plus h as opposed to just plugging in a 3.1. But here's where it starts to get easier. Notice what happened. I have 171 here that came out of this 19 plus 9, or times 9. And then I have a minus 171 that happened when I plugged in 3. And so those parts are going to disappear. That's pretty significant because before I could cancel that. Am I allowed to divide by h if there's no h here? No. And I couldn't divide by h if there's no h here. But since those two constants disappeared, look what I have left over. 114h plus 19h squared all over h. Now am I allowed to divide by h? Absolutely. Since h is in everything, I can divide by h. So if I divide this by h, it disappears. If I divide this by h, one of those h's disappears, not h squared anymore. And divide this by h, and it's 1. So I'm left with 114 plus 19h. So this formula then that I figured out after a little bit of tough work at the beginning, but it canceled out nicely, can describe or estimate the AROC at any length interval I want when x equals 3. So I don't have to start it over again, and if I want to put in 0.01, I can do that. If I want to put in 0.001, I can do it here, instead of having to do it at the start. Let's just verify. So if we plug in 0.1, like we did in the first slide, we should get the same answer. So it's 114 plus 19h, which in this case is 0.1. So that's 114 plus 1.9, 115.9 meters per second. Let's check the first slide to see if that is actually what the answer is. So here it was. I had an h value of 0.1. I did all this work and I got down to 115. Now, if I wanted to change h to 0.01, I'd have to start right from the start, right? And have to start right here. Redo all this sort of stuff and come up with a new answer. But because I've done this formula, I've got a formula for it. I've done all the work once, and now all I need to do is sub in a new h value. So if I go to this final step, if I have a different h value, no big deal, I've got this formula. 114 plus 19 times 0.01. Equals 114 times 0.19. And I get 114 meters per second.